Hello class. For Module 9, we are tasked with creating a VI that duplicates the Wheatstone bridge measurement system. In the Wheatstone bridge you have 3 resistors, all of roughly the same size, and a variable resistor. You have a excitation voltage powering the circuit, and as the resistor changes over here, your output voltage will change accordingly. Alright, so let's get to the VI. So in the VI you have a simulated signal for the 2.5 volts as the excitation voltage, or your voltage in. You can see here that I just set that at 2.5, so that's at a steady 2.5 volts coming in. Alright, to come up with a way to mimic what's going to happen with this, this resistor, I decided to go with a simulated signal. But I set it to 0, and what I ended up adding was a variable slide for the offset. In this way I can adjust the value of this resistor from 500 to 1500 ohms. At a steady state it should be set at 1000 ohms. So I have that ready. Okay. Alright, and that gets us into the formula that was provided in this module, which is your input voltage times your resistors and your variable resistor, and the summation of this equation is the output voltage here. So the output voltage comes out, and you have your R1, R2, R3 set at 1000 ohms, the variable resistor that I just mentioned anywhere from 500 to 1500, and your input voltage of 2.5 volts. So the output voltage comes out and goes to the waveform chart, and also it goes to a secondary formula to calculate the strain. So we go to the properties. This is a pretty simple equation you can find in the book or Googling online. And basically what it takes is the output voltage and divides it by the input voltage times the gauge factor. So the gauge factor is found on the strain gauge packaging. That lets you know kind of what that factor will be for that resistor. Okay, so I made the gauge factor variable in case it's ever something besides 2. I've seen it at 2.14, I've seen it at 2.05. So basically that's going to be dependent on the manufacturer of your strain gauge. The output of this, the resultant, is the strain. So I put a display on the front for the strain. You can see what's happening in real time as these as the strain gauge is loaded and unloaded with a force. For the output writing to a file, we have various columns set up here. Indexing at 0, we have time. We have input voltage at 1. The variable resistor at 2, the output voltage at 3, and the strain indexed at 4. We have a file name. I like to have that on the front so I can see exactly where the file name is, and I have a file output name. This is very helpful if you are creating some new files for each time you run the program. For Module 9 we were tasked with appending to this file here. So when I open the file later, there'll be several iterations where the time starts at 0 and goes until I stop the program, and it just keeps adding to that file. One more thing I have in here is a case loop, and what the case loop does is it gives me a Boolean expression for a switch, which allows me to clear the data from the waveform chart. I noticed that whenever I'd run multiple iterations of this program, the waveform chart would just pick up where it left off, and it'd have all the old data from the previous runs. The best way I could come up with clearing that data is to actually build a case loop within the while loop that allows me to basically set the history to 0 and start over the waveform chart. I think that explains just about everything in this section. Let's go see how the program runs. So we hit run. Right now you can see that there's all this time here, so I'll go ahead and clear that, And so right now the strain gauge is at 1,000 ohms, gauge factor is 2, and strain is 0. This is because there's no change, so there's no change in the output. Alright, so we come over here and we start loading this strain gauge. It's loading. You can see that the resistance is getting smaller and the strain is starting to increase. So right now we are in a compression state, and you can see it's just loading and loading and loading. And then we'll take it back the other direction, go back to neutral, and then we'll start tensioning this. And you can see that the waveform chart is reacting in real time. You can come up and oscillate this a little bit. And so we'll just imagine that that's all the strain that's been happening to the strain gauge. We hit stop. Next, we go to our output file name location. And like I said, this is appending to the old files. So this one was just saved. We'll open it up. And you can see that I have previous iterations on this run. So it starts at time 0, goes down to 7 seconds. We do another run. We do another run here. And I believe that that might be the last of it. Alright, so this is the run we just did. So we started off at 1,000 ohms, 0 output voltage, 0 strain, and we start going. If you remember, I started lowering the resistance, and you could see that it started to show an output voltage. There was a difference. We were no longer in balance, and there was a resulting strain with that change in resistance. You can see all the data points were captured. You can plot this again or use it for whatever you need to determine what kind of deformation is happening in your substrate. All right. If you have any questions or any comments, please let me know. I'm happy to explain what's going on, or maybe I just completely missed the mark. Anyway, you guys have a great one, and I'll look forward to seeing your feedback.